In this video, we're going to work a couple of example problems involving the division of power series. So as I talked about in the previous video where we worked example problems involving the multiplication of power series, the idea is that you can't, so like, you know, if we had e to the x times cosine of x, something like that, yeah, you could get the power series for cosine of x and then multiply that by e to the x and then combine that into to make another infinite sum, and that's completely valid. However, right, so get the power series for cosine x and then bring e to the x inside that a and then combine that with the a sub n, that's fine. However, the problem is what you end up with is not a power series. And so we don't have a way of every single operation we've done, whether or not we've multiplied a power series by 1 over x or whatever, or x cubed, or anything we've done in this section, any of the problems we've worked, we've started with a power series, we've done the multiplication, simplified, and we end up with another power series. And so we can then say that, so if we had like cosine of x, we have that as a power series. We multiply both sides, so cosine of x is equal to a power series. We multiply both sides by x, and we end up with x cosine of x on one side and another power series on the other side. Well, those are equal, and we're done. But if we end up with something that's not a power series on the other side, then we can't, you know, they might be equal, but we haven't learned how to evaluate anything but power series in this course. Okay, but for situations like this, like for e to the x times cosine of x, one option we have is we could multiply the two power series and get, you know, what we saw was that we got like the first, with multiplication of power series, we got like the first 3 or 4 terms of the multiplication, and from there you could, you know, we just stopped there, but you could maybe go past 3 or 4 terms, get like the first 4 or 5 terms, and then see if you can get a pattern from that and create the summation for the actual multiplication, which I believe you need to, at that point, use induction to prove that the formula you found is valid for all n, not just the first 5 terms. But there's been example problems in this section where I feel like we've done that, and like with the binomial series problems, for example, the textbook, the way the solutions, what they do is we come up with a formula, we kind of expand everything out, and then we come up with a formula for the summation, but we don't technically prove that the formula we found is valid for all n, which you could do using, again, you could do that using induction. There's a video earlier in this chapter in the playlist that shows how to use induction. You could do that. So to me, if you found the first, if you did the multiplication or the division, same idea. So you could multiply or divide power series, and then you get the first 5 or 6 terms of a power series, maybe more than that if you wanted to. And if you could get a formula that's valid for the first 5, 6, 7, 8 terms, then there's a good chance that that's going to be valid for going off to infinity. But I guess technically you could prove it with induction. But that's the idea, though. You can multiply or divide power series that's another option for creating a power series from base power series, right? We could always just do the base definition of a power series, you know, get the first 5 derivatives, plug in the center point, and then just build it that way. But we're learning methods for, you could do, starting with base power series like sine x, cosine x, e to the x. You could pattern match, you could differentiate, integrate. But another option is you could multiply or divide 2 different power series to create other power series from base power series. So, okay, what we're going to do here is we're going to use the division of power series to get this. Okay, and so we're going to start with sine x. That's going to be what we're going to build off of. So sine x is the sum from, and these were all found using the definition of the Taylor series. These are Maclaurin series. Okay, so we've got sine x is equal to the sum from n is equal to 0 to infinity minus 1 to the n, x to the 2n plus 1 over 2n plus 1 factorial. Okay, and that's another thing I forgot to mention in the previous video on the multiplication of power series. These were all being built from Maclaurin series, so they're centered, the results are centered at 0. All right, so let's write out, okay, so sine of x is what? minus 1 to the n, x to the 2n plus 1, and this is x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial, etc. Okay, so how do you divide two power series? And well, we're not really dividing two power series. We're dividing just x by a power series. How do you divide either by two power series or divide something by a power series? Right, because we can't, you might say, well, can we just multiply x times this? Well, no, we've got 1 over sine x, right? We need to divide by a power series. So what you do is you use polynomial long division, okay? And so the divisor is x, and then we're going to write out, let's see, x minus 1/6 x cubed plus 1 over 120 x to the 5th. And that should be enough for the first 3 non-zero terms. We're just going to find the first 3 non-zero terms. And then that's the divisor. And then you've got x plus 0x cubed plus 0x to the 5th, you know, plus dot, 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 plus dot, dot, dot. Okay, now we do this for typical polynomial long division, we do this, the polynomials are written in descending order. Here they're written in ascending order. And why we're allowed to do that and how come it still works, you could do your own research on that. I might make another video about that, but you know, because it's confusing, because if you went back to polynomial long division in algebra and you reviewed that and you divided two polynomials and you got an answer, and then you did the same division of those two polynomials but switched from ascending to descending order, you don't get the same answer. So it is confusing, but it's the same exact mechanics as polynomial long division, except we're treating we're writing them in ascending order instead of like x to the 5th or x to the infinity, you know, right? Normally the higher power comes first. We're writing them the other way around in ascending order, and we're just treating this, the lowest order term, as like the largest term. It's the same mechanics as polynomial long division. So, okay, so how does it work? Actually we're going to need 0x squared plus 0x cubed plus 0x to the 4th. Yeah. Okay, what we do is we divide x by the first term, that's 1. And actually, yeah, so I needed another placeholder. So zero plus x plus 0x squared plus 0x cubed plus 0x to the 4th plus 0x to the 5th. Okay, so you would divide 0 by x and get 0, but so nothing happens. So x divided by x, you get 1. So we put that here because that's x to the 0, right? We match those up. And then you multiply 1 times this. So that's x, we put that here. X, and then minus 1/6 x cubed. And then plus 1 over 120 x to the 5th. Okay, now let's dot, dot, dot. We subtract these, and you get x minus x is 0 plus, 1/6 x cubed, and then minus 1 over 120 x to the 5th. Okay, now you divide 1/6 x cubed by x, by the leading term. So that's 1/6 x squared, positive 1/6 x squared. Now you multiply this by this. So you get 1/6 x cubed, and then minus 1 over 36 x to the 5th. And then when going past that, we don't go past that. Okay, so now you subtract these two, and you've got minus 1 over 120 plus 1 over 36. Minus 1 over 120 7 over 360. Okay, now this divided by this is 7 over 360 x to the fourth. Multiply this by this, you get 7 over 360 x to the fifth, and minus, and then now we've got, so that's it. Okay, so this is a plus, this is a plus, and that's it. These are the first three non-zero terms. So we'll put approximately equal to 1 plus there we go. Okay, secant x, you can think about, we could have started, if we had done this problem first, then we could have then come here and multiplied secant, the result we got, by just multiply that by x, because 1 over sine x is secant x. You see, we could have done this problem first, gotten a result, and then with that result, just multiplied x by that. In fact, you can think about, if we divide, we should end up with 1 over x plus 1/6 x plus 7 over 360 x cubed, something like that. So that'll be interesting to see what we get here. But, okay, so this is 1 over cosine x. That's what we're trying to do. That's the division we're trying to do. So, oh wait, no, I'm sorry, no. This is 1 over sine x. So no, that wouldn't have, we couldn't, it's not going to work out that way. This is x times cosecant x. Here we're working with secant, so no, it's not going to, those are slightly different, but okay, so we're the base series we're working with is cosine x. The sum from n is equal to 0 to infinity minus 1 to the n times x to the 2n over 2n factorial. Okay, so which is equal to, so 1 minus x squared over 2 factorial plus x squared over 4 factorial, etc. Okay, so we want to divide 1 by this power series. So, okay, we're going to do 1. Well, let's write out, let's do this first. So 1 minus the divisor, 1/2 x squared plus 4 factorial is 1 over 24 x to the fourth. And that should be good. Okay, so we got just 1 plus 0x plus 0x squared plus 0x cubed plus 0x to the fourth. That should be enough there. Okay, 1 divided by 1 is 1. Okay, minus 1/2 x squared, and then plus 1 over 24x to the fourth. Okay, you subtract these two, and you get, this goes to 0. You have 1/2 x squared, and then minus 1 over 24x to the fourth. 1 half x squared divided by 1 is 1 half x squared. So multiplying 1 half x squared by all of this, you get 1 half x squared and then minus 1 over 4x to the fourth. Okay. This goes to 0, so 1 over 24 plus 1 over 4. Or minus 1 over 24 plus 1 over 4. 6 times 4 is 24. So that's 5/24. Okay, 5/24 divided by 1 is 5/24 x to the fourth. So multiplying that by the divisor. Okay, and then that's it. Okay, so there you go. That's it. So this is approximately equal to 1 plus 1 half x squared plus 5 over 24x to the fourth.